We're now going to walk through the implementation of the client portion of the PrimeCheck app case study. As you'll see, there's a series of classes called PCClient that send and receive HTTP GET requests and then, of course, receive responses to and from the service that's implemented here to do the prime checking strategies. As usual, you can get this code in my EX1 project in the web MVC folder in my live lessons GitHub repository. So let's take a look at the client side here. On the test part, we're going to take a look at client, and we're also going to look at client beans in a second. So you can see here that we've got the various proxies that we've got for, sorry, the interfaces we have here. Let's go ahead and take a look at the one that does parallel stream. So here's the PCClient parallel stream. This is what we looked at before. You can see that we have the proxy there. This is going to do what we showed before. We're just going to basically make a bunch of calls that'll run in parallel. And then down here, we go ahead and make the single call that will run in parallel on the server side. This call will run in parallel on the client side. Here's what the proxy looks like. The proxies are shared by all the different strategies. We could probably have factored this out a little bit better to make it more reusable. But basically, you can see the same thing here. I'll probably go back and replace the use of the naked string literals with string constants to be consistent with my own advice. The thing I want to show you, though, is this really cool feature on the client side. Now, here's the issue. If we, and by the way, just to complete this, so for the parallel stream, you can see that when we do a parallel stream maintains a pool of worker threads using the common ForkJoin framework. And there's about as many worker threads as there are cores on the computer, give or take, just a tad. So there's only a limited number of threads doing parallel calls on the client. Now, if you take a look, for example, at the futures implementation, with Completable Future implementation, this is very similar to what we see on the server side. It's just we're making the proxy calls in parallel using the mechanism for doing Completable Futures. If we do the version that I show here, it uses the common ForkJoin pool. Once again, we have a limited number of threads. That's good. However, for the version of Completable Futures that will use virtual threads and the version that uses structured concurrency, for each invocation made by the client, there's going to be a separate thread that's used for the invocation. Now, if we only have a couple hundred invocations, not a big deal. But what if we try to do 5,000 invocations at the same time? Well, there's only a limited number of connections that are available in a program that uses TCP. So typically, I think it's limited to 1,000-ish or so. And you can play some games to make that limit larger, but after a while, you start running into operating system-defined limitations. So what we're going to do here to work around this is we're going to make a REST template factory method that is going to have a pool of threads. And so this is a mechanism that you can use in order to be able to have a pool of threads. So if we have set the pool connections environment variable, then we're going to use a connection pool. And I won't go through all the nitty-gritty details of this. This is code I cut and pasted from Stack Overflow at some point, but it works. And what it does is it basically sets up a connection pool with up to 100 connections, which is well below the total number of the max number of TCP connections that a client can have open at a given time. So we have a connection pool that's transparently created, and then when requests are made, the requests are basically pooled, or they use the pool, so you never have more than 100 connections open at any given point in time. And so this ensures that we don't overrun the connection resources on the client side because we have a separate thread for each of the client requests when we use either the structured concurrency model, which uses virtual threads, or we use the variant of Completable Futures that uses virtual threads. So I discovered this the hard way because I was testing my program, worked fine for parallel streams, which bounds the number of threads and the number of open connections. Therefore, when I used Completable Futures with the common ForkJoin pool, which again bounds the number of threads and the number of connections. But when I started using structured concurrency and or virtual threads for the Completable Futures, my program started failing in bizarre ways. I'm like, what is going on here? And based on some testing, I realized I was running out of connections. And so this connection pool helped to solve that problem. And what's nice about this is I can totally do this in a transparent way. So this use of beans and injecting this way of creating the REST template, which is, of course, what's used over here for the proxy, that is nice and clean and transparent to the rest of the program. So really cool feature, something you should be aware of if you ever run into something similar, is using REST templates. By the way, something else I probably should do. So this is the typical kind of code you'll get from Stack Overflow, right? It's got a handful of comments, but you're like, what the heck is going on? And as I'll show you later when we take a look at the structured concurrency stuff, ChatGPT is wonderful at being able to take code like this and then generate comments explaining what everything does. So it becomes much more readable. Okay, so that's the end of the client wrapper part.